next session, which is on clean, safe, uninterrupted conveying. And in this session, we'll hear from Mr. Sandip Kumar Day from Tega Industries. I'll just quickly introduce you to the delegates and then we can have your presentation. Mr. Sandip Kumar Day is Head Conveyor Products at Tega Industries. He is experienced in capital equipment as well as mining and metal industry. His main area of expertise include business development, negotiation, and project engineering. Mr. Day has a master's degree in production engineering from Jadavpur Engineering College. Welcome, sir, to the conference. We have around 20-25 minutes for your presentation. And after that, we'll take the questions from the delegates. And I request the delegates to please type in the question while Mr. Day is presenting. Over to you, sir.
Yeah, good afternoon. Is the presentation visible?
Yes, sir, the presentation is visible.
Okay. A very good afternoon to all of you. Today, the subject of the presentation is clean, safe, and uninterrupted conveying. I will like to deliberate on some of the critical points associated with it and also slightly touch upon the issues, why it is easier said than done. I was listening to the morning sessions where a lot of spillage management issues are being talked about, are housekeeping issues. Yes, there is no doubt about that, that housekeeping is very important to have a spillage-free kind of an operation. But there are certain other important issues that definitely need to be taken care. I think for this presentation, I would like to touch upon all those points specifically. Let us go back a little bit back into the history. In 1905, actually, the belt conveyor was first used by Richard Stucliffe, was an Irish miner, which actually revolutionized the mining industry. In the next 100 years, it became the most efficient way and maybe the most cost-effective way of handling the materials. But the problems that were always associated with this system was that the problem of the spillage. Now, in the last century, we survived with it. But in the 21st century, when the safety norms have become stricter, the environmental norms are also become much more stringent. The productivity standards have gone up. This is definitely a subject of discussion and needs to be deliberated in a little bit more details from all concerned in the industry. We all want this. We all say we all want this clean, safe, uninterrupted conveying. But unfortunately, this always does not happen this way. Now, if you visit many of the plants in the country even today, like at this time of the year specifically when it's monsoons, these are some of the situations you will very easily come across. Like these are quite frightening pictures, but they are not very uncommon pictures. So this is sometimes really scary when we go into a plant and we are encountered with this kind of a situations. And I just can feel the pain of the people who have to operate the plants day in and day out and they get the best production out of it. All these are very simple. It will increase a lot of maintenance cost of both workmen and the equipment, the production loss due to unscheduled shutdown, less life of belt idlers, pulleys. There will be high cost because the materials will not be salvaged. Power will increase. We all know this. But the question that comes to our mind is that why do we land up into this kind of a situation? The plants are ultimately designed by engineers, they are run by engineers, they are maintained by engineers, and we are all concerned about the spirit. But where actually is the gap? Why we we land up in this kind of a spillage, which is not very uncommon. Like these are the pictures that are taken from the plants all over the country, and as I said that again and time and again, that these are quite common pictures, and obviously the people who are here today are associated with this industry and into this plant are also aware that these exist. Now there can be many reasons. Not one reason cannot be a factor. Some of our observations over the years I just put in, and I will just try to go into some of those observations and points and try to elaborate them. Maybe some of the points will exist in one plant, some of them will exist in the other plant, but overall, it can be summed up in this way. Conveyor systems are designed there are always focus on design based on like the power consumption, based on today important is also that you are designing it for the safety. I think a more focus has to come from the point of designing it from the point of the spillage management also. Obviously, this presentation cannot cover those subjects here, but I will take up a small one example just to elaborate like what are the kind of things that we generally face, which is a constraint for better spillage management in that conveyor. Today, all the plants are also under constant pressure to produce more. So sometimes what is happening that the conveyors are being used at a higher capacity than it was originally designed. That also creates a lot of spillage. The third important issue is that efficiency of the product, and efficiency is a very word which can be used in a very wide spectrum. We will talk about efficiency, and we will look about the total efficiency of the operations and how it can affect the spillage management. And also we do believe that only this spillage management products and all these just cannot stop spillage. So there is something more to that to understand the root cause and all. I will touch up on those points a little bit on that. Now, moving forward, like I just take two small examples. Like it's about like when we go to the plant and find that the spillages are happening. I'll just explain a little bit on that. A picture on the left, if you really see, you can see that a lot of spillage, material spillage on the side of the conveyor. Now, if you look at the size of the spillage material, and you have the scud sealing system in place, although the scud sealing system is quite a traditional product, and probably it will not the best product being fitted in the system. But still, the amount of spillage that you can see, the size of the spillage that you can see, it clearly depicts that it has not happened because of the scud sealing system that is there. What is probably happened here is that if you really see that the scud board side plates are absolutely at the side of the belt. Like many a time you come across like this kind of loading stations where the scud powder plates are really at the edge of the belt, and as soon as there is a little bit of a sway of the belts, you have a lot of spillage on it. Now what happens? This is supposed to be like not more than 2/3 of the belt width. Sometimes we ignore that. We don't stick to that, and we land up into this kind of a spillage problem. Let us take an example from the discharge side. If you look at the discharge side, this is a perfect kind of a situation where a belt scraper is put under the belt between the nick point and the snug pulley, and it is scraping the material, and the material is flowing into the chute. And this is supposed to be the chute back plate, and all the material you are getting into the chute. But in many cases, like when you because you need this product, you need a good scraper to be fitted, and if there is not a good scraper to there, and you have a lot of spillage. I will come to that what kind of spillage that can happen, and what is the quantum of the amount of material that can be on the floor in my subsequent slide. But here, I just like to show that many of the cases you will find that you have the chute back plate in a kind of a position where you do not have any place to put up a good scraper. Now, at this kind of a situation, you compromise the whole thing and you put a belt scraper somewhere near the knee point, but it will not perform even to the 50 to 60% efficiency that a good scraper that it will be able to perform when you have it in the right installation place. So these are like some small things. There are numerous other things like small things that are there which can help to reduce the spillage. Like this is not about the product. Product can be there, but then like small adjustment and small design changes can solve a lot of problems. Now, yes, there will be spillage, and if you tell that there will be housekeeping to clean it and all, you keep on doing that job, and that sometimes is not possible. So we have to address it through changes in the design. It can again, as I said, that it is not a scope of discussion today. There can be various ways to do it. It's about the modification of the shoot back plate, shifting of the head pulley and all. But then what I mean to say here is that the focus has to be there on the design from the view of the spillage management. Let us talk a little bit on the efficiencies now. Now, this is what we all do. Like the conveyor belt will spill material throughout the length of the conveyor at the loading station, during conveying, and at discharge. Now, the sealing system in the loading station is bad, and obviously there is a lot of spillage out there. Maybe the belt is swinging. That's why you have a lot of spillage while conveying. And again, at discharge, there are a lot of carryback spillage coming in. But we must be aware of how much spillage in the loading station can be allowed. What is the acceptable level of the belt swing? What should be the efficiency of the belt scraper? Now, Peter Drucker says that what cannot be measured cannot be improved. Like this is the scenario, like these photographs again, like it shows you that there is so much of spillage in the loading station, the belt is swaying, it is cutting the structure, the steel gets cut, and also at the same time the steel cutting rubber. The costliest part of the conveyor system is the belt is getting damaged. You have, because of the carryback spillage, so much of material on the floor. So at least certain benchmarks has to be there. I have not come across any specific benchmark to this, to our standards that are available. But then some of the good global practices I just can put in, like when we talk of the loading station, it should not be more than 5 kg per meter of the loading length per day. But that the maximum, if it is the lumps, it can be a little bit lower. In case of fines, it can go up to 5 kg per meter, and that's without stretching too much. Even the belt weight has to be restricted within the 5% of the belt width, and as we say that the scraper efficiencies can be something between 90 to 95%. So these are absolutely not very difficult things to achieve. But then yes, to achieve this, there has to be certain operations the condition has to be there, and that obviously is a part of that, because if you don't do that, obviously these efficiencies will be difficult to achieve. When we talk of efficiency here, we need to keep in mind that we are not talking of efficiency gap of a big number. Here we are talking of efficiency improvements of 2%, 5%, and those itself are huge number. Like when you see a lot of material all over the floor or all your loading station, that's all because of the difference in efficiency to the extent of this is the level of difference that is there. It is not about that it is 30% difference and all. So we should be seriously be attuned to the fact that the small improvements can create a lot of difference in the actual results that you get at the site. I just give you an illustration to this. It's a simple illustration to understand that when we talk of spillage, from this so much of huge material is coming from. This is a carryback spillage we are talking about, and that's a very old calculation, and that's a very proven fact. Now, the video on the right is showing that there is a small layer of material that is sticking, that is showing that material, when you are just trying to clean it, and you can see the material is coming out. The example what we are talking here is that about a conveyor belt which is 1,000 millimeter wide, and it is running at a belt speed of 2 meters per second, which is a very modest speed. And by today's standards, most belt speeds are higher than that. All modern conveyors today are being designed at a higher belt speed. When you have that kind of a conveyor and when you are having a 0.1 millimeter of material sticking at the return side of the belt, and remember that we are talking of 0.1 millimeter, it is about 43 wagons of 20-ton coals on the floor at the end of the year. So that's a huge amount. So when these are the amounts of material that gets deposited at a belt of like 1000 millimeter at a 2 meter per second belt speed and with a residual layer of 0.1 millimeter, you can think of a situations what can happen in the actual scenario where the carryback level layers are much higher and obviously the belt speed is much also higher. I take an example from the two plant, a power plant again here, which is handling coal and having a carryback of around 1 millimeter, which is again very common. Having 40 conveyors of 1400, just for calculation's sake, it's a 1400 millimeter belt width, because in power plant 1400 belt width are the most popular ones. A belt speed of 3 meters per second, operating for 16 hours a day for 250 days a year. Because of the 2% difference in efficiency, you will have around 11,000 tons of material extra on the floor. So that's a huge quantity. And that actually happens every time. All the pictures in the slides that I have shown you in the beginning are actually the representation of what is happening. The happening because of the difference in the selection of the product, which are probably good for some other applications, may not be good for that particular applications. It is not able to achieve the efficiency that it is supposed to achieve, and you are ending up into that amount of material on the floor. So this is my whole idea of showing you this is to sensitize the fact that when we are talking of the spillage, we are talking about a huge amount of material at stake, and a little bit of a difference in efficiency can create a lot of difference in the quality of the cleanliness, or what you can say, that's management of the spillage that you can have at your plant. So efficiency of the scraper will determine how much of the material will on the floor. Now again, the efficiency of the word has to be defined a little bit in a bigger context now. Now efficiency is not only about the product efficiency. Just to depict it, like there are various kinds of products available at any point of time in a market. Now the graph on the right side shows 4 types of graphs. Like suppose a product is having a peak efficiency of 85%, something as 90%, maybe something as 95%, and maybe some other product is around 90%. Now, over time, the efficiency goes down. Now, this is also a very important criteria, at what time you will require this product to get its service to regain its original efficiencies. So, you will find some of the products that will be requiring service in 2 weeks' time. Some of the products probably will require servicing in 4 weeks' time. And then the other products that will require servicing in 6 weeks' time or even beyond. So if we are not servicing the product in time, even the efficiency of the best product, probably having an efficiency of 95%, will go down to 90% in no time, or even 85% in no time. So we again have to be aware, and we need to look into the situations where we should be able to select a product, completely be aware that the capability of the team at site to service it, that by what time it will be serviced, so that the average efficiency that you can derive out of the product is at the level that you think that it suits you. So the service part of these kind of products will be completely related and add to the overall efficiency of the whole system.
Mr. Day, another 5 minutes for your presentation, 4 to 5 minutes.
Yeah. Basically, like as I was talking about, like there are many products which can be good at a particular circumstances, but then there are applications which are different, which are difficult, and again, if the selections and if the product selection is not done in that respect, we can land up again efficient product in some other conveyor can be proved to be very inefficient in those conveyors. So this is one just photograph, just video I just wanted to show you. You just have the look on the right side of the beyond the belt scraper that is being shown. Just look at the cleanliness on the top right corner, on the bottom middle, again on the left also on the right side, which is you will understand the kind of the cleaning that is achieved today, because today the products are available to achieve those levels of efficiencies. But then again, it is again application based. But then the products can support that. It can give you the level of the cleaning, and as I was saying, that even a 0.1 millimeter kind of a thickness of the carryback can create a lot of. Not have the time to talk about all the kind of the efficiencies of the product, but then just to have a small brief here. Even when we talk of the belt scraper, the traditional system that we have over the years are the kind of areas where you can see on the kind of systems that are generally being used. And when it is being used this way, the basic principle is that the side rollers will push the belts back to the center, and the whole system rotates on a thrust bearing. But this kind of a system does not perform, and it gets jammed very fast, and it starts damaging the belt edges also. So there are systems available today which does not have this kind of a disadvantage, which are much easy to use, easy to replace, and you can get the best results out of it. Like as I was saying, that you can achieve up to less than 5% of the belt sway. Of 5% of the sway, less than 5% of the belt field. Similar are the issues in the loading stations. You have to have a proper sealing. Even today, people are using lateral strips, which does not do a good job. While loading under pressure, it creates a lot of spillage all around, where the segmented block must be used so that you can have a complete sealing. And it has been proved time and again that the kind of the spillage that the lateral strips does, you cannot have a kind of a cleanliness that we are talking in today's 21st century. As far as the supporting of the belts, similar developments have happened. Similar improvements have happened where the impact idlers are getting slowly being shifted because of the damages it is happening, because of the kind of the vibrations it has, because of the maintenance is required. Traditional impact bed system was a good option, and even now today there are better products than that, which gives a complete support to the belts, and which are much easier to install and at the same time much easier to replace. So those kind of the impact bed system, as we call a jumbo impact bed system, those can be more easily integrated into the system and can give a much better result to the conveyor belt. Now that's the whole idea, that it should look like this, like a picture on the left with all the rollers and the lateral strip skirts with so much of spillage, and on the right, when you have the impact bed system where the belt fully supported along with the segmented skirt sealing system, you have a very, very clean system in place. Just to come to an end, like only products cannot make this transformation happen. Picture on the left with so much of spillage, and on the right, we did actually in a particular steel plant, this has been done some time back. This cannot happen just by only because of the product. We have to, when you can't land up this kind of a situation, the whole problem has to be diagnosis, has to be done, analysis has to be done, a customized solution has to be derived, and then only you can achieve this. I just give you a small example to this, like why this is very important and it is required to be done this way. Like if you have a problem of a belt sway, so why it is moving off center? Because there are some unbalanced forces in the system. Now, how to control the sway then? If there is sway, it is having a sway. you will try to give a counterbalance force by using the tracker. That's the easiest option. Like it's a paracetamol to the fever. But then, but if you are not solving the actual reason of the fever, what happens that you will overuse the paracetamol and may not sometimes get the best result out of it. So it is important that you find out the cause of why this unbalanced force is happening, and we eliminate it and reduce it, and then probably we solve it. Many a times we found that there are spills way, and it is not because of something else. Because of a lot of carryback, the rollers are lapped with material, and it is because of the carryback spillage being left on the rollers, and it is giving you a unbalanced force and belt is swaying. Putting up a good scraper into place, you don't have the sway anymore. So those are the kind of the things that you don't need to just fight symptoms. We need to go into the root cause analysis. So at Tega, what we do, for any kind of this kind of a problem, we diagnose the whole thing. We do a comprehensive audit of the conveying system as a whole. We have our internal softwares to do it. Other than we have also experience of handling more than 40,000 conveyors. We tailored an engineering solution. The most important part of it is that the installation planning. Because as I said, even if a good product is installed in the wrong place, you will not get a good result. So that has to be followed up with the installation support and commissioning and beyond. So when you do that, obviously you get the result that is your expected, and we can give clean, safe, uninterrupted conveying. Thank you.
Thank you, sir, for a very informative and insightful presentation. We'll just take a few questions that have come in. So the first question is, are C-series scrappers sold in volumes now by Hosh in India?
Sold in volumes, the volumes has a like context to them. For me, it is yes, it is volumes. We are doing it for a few years now, and now it has really picked up. And we have made a very good number of not only sales. Sales is the secondary part of it, and we have got extremely good results in various different areas that are there in India.
Okay. So the next question is, can we change the lagging on the tracker? Which MOC of lagging is preferred, rubber or polyurethane or ceramic paste?
Yeah, that's actually I did not go into that presentation in a detail because that's the move forward. Like this is the third generation of the tracker we are talking about here, where the small rollers are replaceables. So whenever you have that problem, the separate rollers is getting replaced, so you don't really need to replace the lagging part of it. But the rollers, small rollers, they are replaceable rollers, and they will get replaced. You don't need to replace the entire the tracking system. As far as the rubber and PU is concerned, rubber is always the best material to do because rubber gives you a better tracking force. But in certain applications where even the best of the rubber is not giving enough life because of maybe there can be certain issues, certain nature of the material, and customer wants life over sway, control of the sway. And only in those cases the polyurethane laggings are generally preferred. These I will presume that are, see, basically what happens, you have a very bad belt with a very strong sway on and for either on the left or on the right or maybe on the both. And those are the cases, applications, rubber is always will be the preferred. But then you have little sway, it is not so harsh conditions, but you want very long life out of the whole system. Definitely the polyurethane lagging can do a good job.
Okay. So there's another question regarding the sealing system. So does segmented skirt sealing system lead to material spillage from the gaps in between the segments?
No, not at all. That is, see, basically, again, that is the presentation I have not done. If you have, I can give the details out of it. Like that, it is designed in such a way that the blocks has parallel guides behind, and those block slides as per these guides, and all the blocks when fitted, they are a little bit on a press kind of a feed. There is absolutely no gap between that. And those blocks are being fitted with the serrated clamp, which does not allow the movement of the block from down to up. It can allow the movement of the block only in one direction from the top, and it is completely safe. So since it is being a little bit of a small interference feed, and it can only move perfectly downward. It can only have a movement that will not create any gap between the block.
Okay. So another question is any scrapers available if belt is running with patches?
See, the scrapers are available for that. The question is, these are all like the stopgap things you use. When you use patches, if the patches have been done well, it is being used. But then obviously you compromise on the efficiency that you will get out of that.
So can you
yeah.
No, so continue, sir.
It will never be able to achieve. It will never achieve the efficiency when you have a good clear belt, because here the whole idea is to not to have the spillage, and that's the primary criteria, that you have to have as minimum spillage as possible. Now, if you have patch, yes, you have to get the second best option that is possible. You maintain the spillage to a lower level, and at the same time you don't damage the belt also.
So the next question is regarding the efficiency. So can you compare or measure the efficiency of the scrapper with each other?
Yeah, we can do, but that's not the forum we should do it here, because that's definitely there, and we keep on doing the carryback test in all our customers, all our major customers throughout the country. We do carryback test. We measure the efficiencies, and we have significant certificates from all of them as far as the efficiencies are concerned. So yes, we do.
Somebody also wants to know what is the efficiency of belt scrapper that Tega has.
It will be a general question. As I said, that the efficiency for one application for a scraper can go absolutely different for different applications. So what I can say that when you are talking of a belt scraper, a very good belt scraper should be cleaning at efficiency of at least 95%. So provided the other conditions are clear, these efficiencies goes even up to 98% under good circumstances.
So just one last question. Do you think the HDPE rollers can work better?
I did not get that question, because HDPE roller, in the sense that tracker rollers, he's talking about HDPE. I said that rubber rollers are always better because it generates a higher traction force.
Okay. So maybe you can share your email address in the chat window, and the delegate can contact you directly in case he has further queries.
Okay, I will do that. Thank you.
So on that note, we'll end the session. Thank you so much for joining us today, and it was a very informative and interactive session. Thanks a lot, sir.
Thank you.